Okay, so this is just to go through how metals are extracted from their ores. Just take note that comparing the new syllabus and the old syllabus actually has a bit more focus on this, but the new syllabus is just a more touch and go kind of thing. Okay, so in terms of extracting metals from their ore, I think first thing we need to understand what does it mean by the ore. Okay, so take note, an ore is a compound of the metal, usually either metal oxide, metal sulfides, metal chlorides, or metal carbonates, mixed with large amounts of earth and rock. So it's not just the metal compound itself, but there's a lot of other impurities as well. So how do they go about getting the metals out from this particular ore? Okay, so there are two ways to do it. One is using what they say, reducing the metal compound to the metal using carbon. So that's one way, using carbon to extract the metals. Now, when they say reducing the metal compound or the ore to the metal, right? Take note, this ore actually also contains, remember, as we see at the top there, there's earth, there are rocks. So there's a lot of impurities in this ore, okay, in the midst of this extraction. Next one we can actually use is also electrolysis. Though we didn't really cover electrolysis so much, but just take note, it's using electricity to break down the compound so that it can get the metal. Okay, so you are breaking down the compound, break down compound. Break down compound to get the metal. Okay, now so the key idea here is, so which one should I use? Should I use method 1, which is using carbon to extract the metal from the metal ore? Or should I use 2, electrolysis? Now, generally, there's two ways to look at it. The first one is using the position of the metals in the reactivity series. Okay? So the more reactive the metal is, the harder it is to extract. So if we look at the metal reactivity series, right, I think at the bottom here later on we'll see, the more reactive metals, we will tend to use electrolysis. Okay, the less reactive metal, we will tend to use carbon. But so when electrolysis, when to use carbon, I think that's the main question that we'll ask. So the key actually comes in here. Okay, so if the metal is found below carbon in the reactivity series, then we will use carbon to reduce them. So we'll use method 1 if it is found below carbon. Okay, anything that's above carbon, we will use electrolysis. Okay, so we'll scroll up here. So you can see here, all of carbon is over here. So carbon is actually over here, this carbon. Carbon is actually over here, right, in the reactivity series. So it's a reference point, right? So anything below carbon, all of this can be extracted by reduction with carbon. So take note, need not only be just purely carbon. Carbon monoxide can also be used as well. So carbon monoxide is also one way of using carbon to reduce it. Okay, so take note, it's not just purely carbon. You can also use carbon monoxide, okay, because it's still a carbon compound. Now take note, it cannot be carbon dioxide. You cannot use carbon dioxide to reduce the you cannot use carbon dioxide to extract the metal from the ore. Only either carbon or carbon dioxide. Cannot be carbon dioxide. This one no go. Okay, so electrolysis are for this 4. Anything that's below carbon, which is all the rest over here, we will extract by reduction with carbon. So question some people ask is, all these can use electrolysis? Okay, can use electrolysis? Question mark. Actually, answer is yes. Electrolysis is actually the most powerful method used to extract the metal from the ore. However, why we don't use electrolysis? Because this method is actually very expensive. Okay, it is very expensive. So unless required, otherwise we will try to use reduction by carbon. Okay, we will try not to use extraction by electrolysis. Okay, so all these can use electrolysis, but we tend not to use because it's expensive. That's why we think in terms of extracting it by reduction with carbon. Okay? Okay, so some of the reactions here, as you can see at the top. So zinc oxide, you add carbon, you get zinc and carbon dioxide. Lead 2 oxide, you add carbon, you got lead plus carbon dioxide. So actually you realize this is actually a displacement reaction also. You can see it like a displacement reaction. Okay, So the more reactive element, which is your carbon, displaces the metal from its compound state, okay, from its compound. So this is the displacement reaction. Displacement reaction, do take note as well, is actually a redox reaction also. So displacement reactions are also redox reactions. Okay. So let's see, anything else? Yeah, actually nothing else, right? So this will be it lah. Okay. That's all.